All right, guys, so I know you're all excited because you have a couple days off of school. Maybe you're watching this at the beginning of your break, maybe you're watching at the end. It is going to be a little bit of a longer video because it's going to have us review a little bit of something we've already done, but also look at two big new theorems that are really important in calculus. So bear with me. I know it's going to be a lot of information, but we will meet to practice this when I see you in class after Thanksgiving. So here we go. Let's start with the intermediate value theorem. What we need to do is kind of review this because after we review the intermediate value theorem, we're going to then learn about two new theorems. We actually learned the intermediate value theorem in chapter 2 of our class. The intermediate value theorem says, and here before we start, intermediate means in between. The intermediate value theorem says that if we meet the conditions, or the ifs, then we can draw certain conclusions about a function. The conclusions are like the thens. So the intermediate value theorem has two ifs. If f of x is continuous, and if the number we're trying to verify is in between the y values of the endpoints. So the number we want, f of x to equal, is in between the y values of both of these endpoints. Then here's what we can say. As long as we're continuous and the number that we want is in between the numbers of the endpoints, the y values, then we can guarantee that f of x must be equal to, is guaranteed to equal that number that we wanted. So f of x, so we usually say like f of c equals m, at some x value on the interval by the intermediate value theorem. So that's kind of the wording of the theorem. If you think back to when we learned this, this is when I showed you a video of a speedometer and the middle of the video cut out. And we said, well, is there any speed that you can guarantee you must have traveled even though you couldn't see the middle of the video? And we agreed that we can guarantee we traveled at all of the speeds that were in between the ones that we knew, because there's no way to jump around. Our function was continuous. The numbers we can guarantee are in between the numbers we know, and we can do that by the intermediate value theorem. What we use it for is when we are trying to guarantee a specific output value for a function. Or sometimes if we are trying to determine whether a function ever attains a specific output value. Now what we say is that, so like this is kind of like a fill in the blanks thing, since f of x is continuous and f of b is less than m is less than f of a, or depending on what numbers you have, this is reversible. It could be f of a is less than m is less than f of b. It just depends on what order they go in. F of x equals your desired value m for some x value on the interval a comma b by the IVT. So I know that we're asking you to kind of go really far back in your memory and remember how to do this, and I thought we could maybe start by me showing you one example of a problem that we've done before to sort of refresh your memory. If f of x equals x cubed minus 2, does f of x equal 0 somewhere on the interval between -1 and 3? So step 1 would be to calculate f of -1 and f of 3. So I'm actually calculating the y values at these two different x's. To figure that out, I would take the -1 and plug it into my original function. -1 cubed is -1 minus 2 is -3. 3 cubed is 27 minus 2 is 25. Step number 2, is f of x continuous? We need to verify that. Well, yes, because it's a polynomial, there are going to be no jumps or discontinuities. No jumps, no holes, no asymptotes, nothing like that. Is 0 between f of -1 and f of 3? Well, yes, 0 is in between -3 and 25. So we would say that f of -1 is less than 0, which is less than f of 3. Using all of this information, we would write our final answer like this. We would say, since f of x is continuous and f of -1 is less than 0, which is less than 3, f of c equals 0 for some c value on the interval -1, 3 by the intermediate value theorem. And the only parts of that really changeable are this part, what the number is that you want to equal, and what the interval is that you're filling in. Everything else should kind of just stay the same and you're filling in the blanks. So now what we would like to do, because this is the second time we're seeing it, is show you an example of a multiple choice question from an AP test that used the intermediate value theorem. It said, let f be a continuous function on the closed interval between -3 and 6. If f of -3 is -1 and f of 6 is 3, then the intermediate value theorem guarantees which of the following? Well, as soon as you see intermediate value theorem, the first thing you want to check is that you meet the conditions. The first condition is continuity. So is your function continuous? Well, it tells me in the instructions that we have a continuous function, so the answer is yes. The second thing is that you need to check your end values, which they give us here. F of -3 is equal to -1, and f of 6 is equal to 3. So we can guarantee f of x equals any number in between. So let's see if any of these say that. The first one says f of 0 equals 0. Well, even though 0 is in between -1 and 3, we can't guarantee that we equal 0 specifically at 0. We just guarantee that we equal 0 somewhere. So this one, we cannot guarantee f of x equals 0 at 0. We can just guarantee it happens somewhere. So this can't be the right answer. Can we guarantee that the slope equals 4/9 for at least one value between -3 and 6? Well, the intermediate value theorem does not allow us to guarantee anything about slope. So this one's out. Can we guarantee that our function is always, our y values are always between -1 and 3? Well, not necessarily. When we did our speeding problem, we said if our speeds went from 20 to 40, you could guarantee the numbers between 20 and 40, but that doesn't mean you didn't go 50. It just means you can't guarantee it. So we can't guarantee that our y values are always between -1 and 3. Can we guarantee that our y value is equal to 1 for at least one value between -3 and 6? Well, yeah, because 1 is in between 1 and 3. can we guarantee that we equal 0 for at least one value between -1 and 3? Well, we could guarantee we equal 0, but it would be for the x's that are between -3 and 6, not between -1 and 3. So D is the only option. Now that's sort of a review, and we had this video that we were able to watch to sort of give us the basic idea of the intermediate value theorem. But there are two more big theorems that come up a lot in calculus, so we're going to spend a little bit of time going over those two theorems now. Oh, just kidding. We're going to do a table problem, then we're going to go over two more theorems. So the next problem is also an AP test question. It's just this was a free response question instead of a multiple choice question. It says the functions f and g are differentiable for all real numbers. The table gives the values of the functions and their first derivatives at selected values. The function h is h of x equals f of g of x minus 6. Explain why there must be a value r between 1 and 3 such that h of r equals -5. As soon as you see that you are trying to guarantee a specific y value, you know you need to use the intermediate value theorem in your answer. So step 1 is to verify whether or not we are continuous. In the directions, it says that my functions are differentiable. If we are differentiable, we must be continuous. And the reason for that is because if you were not continuous, your derivative would not exist. That's one of the types of non-differentiable spots. So since we're differentiable, our function must be continuous. So step 1 is going to be to find h of 1, which is the value of one of the endpoints, and h of 3, which is the value of the other endpoint. Now it says here in the instructions, h of x equals f of g of x minus 6. So h of 1 would be f of g of 1 minus 6. Now g of 1, if I go to g's column, where x is 1, is 2. F of 2, so this is really 2. So now if I plug the number 2 into f of x, I get 9. And 9 minus 6 is 3. If I try to evaluate h of 3, f of g of 3 minus 6 would be g of 3 would be 4. And if I plug 4 into f, I get -1. And -1 minus 6 is -7. Now it says explain why there must be a value r between 1 and 3 such that h of r equals -5. Can I say that -5 is in between 3 and -7? Well, yes. So the reason is going to be because of the intermediate value theorem. So we would say, since h of x is continuous, and let's see, h of 3 is actually the smaller one. H of 3 is less than -5 is less than h of 1. H of r, and I'm using the letter r because that's what was in the instructions, equals -5 for some value r on, and I'm going to write my interval the same way that they wrote their interval. We're just going to be consistent with the instructions by the intermediate value theorem. Now we're going to look at two new theorems. There we go. The extreme value theorem is probably the least commonly used theorem. What the extreme value theorem talks about is extrema. So, maximums and minimums. It's got the most basic conditions. The only condition, the only if in the extreme value theorem is that f of x has to be continuous. And it gives us the most basic result. What it says is that as long as you're continuous, the then would be that we are guaranteed to have both a max and a min on our interval. We use the extreme value theorem when we are trying to guarantee that a function has a max, or we are trying to guarantee that a function has a min. And what we say is kind of like what we said for the other theorem, for the intermediate value theorem. We say since f of x is continuous, because that's our condition, and closed, I'm sorry, I forgot what word I meant to write there. F of x is continuous and closed. And what we mean by closed is that it has endpoints. It doesn't just keep going on forever. F of x is guaranteed to have a max and a min on the interval by the extreme value theorem. So let's take a look at number 1. This is literally the only AP test question that I could find that just used the extreme value theorem. This is like, it doesn't come up that often. If f is continuous for a to b, differentiable for a to b, and you'll notice this one's open and this one's closed, f of a equals 3 and f of b equals -7, which of the following must be false? Well, if we're trying to figure out which one must be false, it's easier to figure out which ones are true. So, can we guarantee that f of c has to equal 0 between a and b? Well, this is an IVT question. Because the first y value is 3 and the second y value is -7, 0 is in between them. Therefore, I have to equal 0. So yes, this is true. Do I have to have a maximum? Well, I'm differentiable and continuous. So the extreme value theorem says I have to have a maximum. F of x does not have a minimum. Well, the EVT says you have to have a minimum. So this guy is false. The last one would be f of c equals -2. Since -2 is in between 3 and -7, I could guarantee this by IVT. As a note, if I'm just being honest, the extreme value theorem is really only used to remind us to check the endpoints when we're looking for maximums and minimums. So what we did earlier in this chapter where we said you always have to also look at the endpoints, same thing. You always have to also look at the endpoints. All right, let's take a look at the last theorem. And this might be the single most important theorem that we've learned so far. The mean value theorem. Whew. The mean value theorem talks about averages. Because in math, the word mean means average. So here's what the theorem says. The conditions, the ifs. If f of x is continuous, and if f of x is differentiable, then, and we're going to write down a formula. This is the only one whose then is a formula that you need to use. Then f prime of c equals f of b minus f of a all over b minus a for some c value in the interval a to b. So what does this really mean? We know that prime means derivative, but another word for derivative was instantaneous rate of change. And we remember this formula as regular old slope from like Algebra 1, y2 minus y1 over x2 minus x1. We called this average rate of change. So what this theorem says is, if your average slope is a certain number, your derivative has to equal that number at least once on your interval. If you think about this in terms of driving, let's say you're driving on the highway and your average speed was 50 miles per hour. That doesn't mean you went 50 miles per hour the whole time. Maybe sometimes you went 75 and sometimes you went 25. The average would still be 50. But you had to have gone 50 at least once. So, we use the mean value theorem when we are trying to guarantee the function has a specific slope. Or when we are trying to locate the places where a function's average rate of change is the same as its instantaneous rate of change. And what we actually write, so just like in the other problems, here's what you would actually write as your explanation. Since f of x is continuous and differentiable, f prime of c has to equal f of b minus f of a all over b minus a for some c value in the interval from a to b. Woo, you can't see what I just wrote. Just kidding. I moved it. I'm going to give you a second to write. I know that really is frustrating. I'm sorry. Sometimes I can't tell what you can see and which can't see. All right. So what kinds of problems might you do? These are actually two very common AP test questions. And what they say is, find the values of C that satisfy the mean value theorem. That's all they say. So to satisfy the mean value theorem means we satisfy this formula. The mean value theorem says f prime of c equals f of b minus f of a all over b minus a. Now this is an equation, and it's an equation we're going to have to solve. So when we're solving equations, we're going to work on one side at a time. Let's work on the f prime of c side. This is basically saying take the derivative and plug in c. So first, I'm going to take the derivative, which would be negative 2x plus 8. Then I'm going to plug in c. So this side of my equation is negative 2c plus 8 equals. Now let's work on the other side of the equation. F of b minus f of a over b minus a is saying do the slope between 3 and 6. So I would have f of 6 minus f of 3 all over 6 minus 3. Well, let's simplify. To figure out f of 6, I would take the number 6 and plug it into my original function. So I would have negative 36 plus 48, which is 12, minus 17, which is negative 5. Then I would plug in 3. So I would have, let me make sure I did that right, negative 36 plus 48, yeah, 12. Okay, good. Wait. Negative 9 plus 24, which would be 15, minus 17, which would be negative 2. Now I'm going to simplify again, because 2 minuses make a plus. So my equation is now going to say, and this is going to be the simplified equation that I actually solve, negative 2c plus 8 equals, now negative 5 plus 2 is negative 3, divided by 3 is negative 1, and then I would solve this. So I would literally just solve this the way I did in Algebra 1. I would subtract the 8 on both sides, and I would divide. What this means is that my slope at exactly 9 over 2, or 4.5, is going to equal the slope of my average rate of change between my endpoints. Let's try this again. So again, the mean value theorem sets up an equation. F prime of c equals f of b minus f of a all over b minus a. When you have an equation, you need to do one side at a time before you deal with the whole thing. So to figure out f prime of c, first I would take the derivative, then I would plug in c. So my derivative would be 2x minus 2. My derivative with c plugged in would be 2c minus 2. F of b minus f of a all over b minus a means f of 3 minus f of 1 all over 3 minus 1. Now, in order to figure out f of 3 and f of 1, I would just take those numbers and plug them into my original equation. So if I plug in 3, I get 9 minus 6, which is 3, plus 1 is 4. If I plug in 1, I get 1 minus 2, which is negative 1, plus 1 is 0, all over 2. And 4 divided by 2 is 2. So my final equation, the one that I'm going to solve, is going to be 2c minus 2 equals 2. If I add the 2 on both sides, I get 4. And if I divide, I get 2. So that would actually be my final answer. Which means at x equals 2, my average slope and my instant slope are the same. Now these are the most common AP questions. So on the next page we're going to go through a few AP examples just to give you a taste. Here are some multiple choice examples that involve the mean value theorem. It says in the diagram below, the graphs of 4 functions are drawn. How many of these functions do not satisfy the conditions of the mean value theorem? So the conditions are 1, my function needs to be continuous, and 2, my function needs to be differentiable. Let's start with continuous, differentiable, there we go. So which graphs are not continuous? Well, this one's not continuous, and this one's not continuous, because this one has an open circle, and this one has an asymptote. Differentiable. Well, derivatives don't exist at corners or vertical tangents. Since this graph has a corner, this one's not differentiable. This one is all nice, smooth, and connected and ready for us to go. So how many of these do not satisfy the conditions? Well, 3 of them do not satisfy the conditions. Number 2, if the function f is continuous between negative 2 and 2, and f of negative 2 equals f of 2 equals 0, if there is no c between negative 2 and 2 for which the derivative equals 0, which of the following statements must be true? As soon as the problem says something about the derivative equaling a certain number, I know I'm thinking about the mean value theorem. Now the mean value theorem says f prime of c has to equal f of b minus f of a all over b minus a. So let's see what f of b minus f of a all over b minus a would be in this problem. Here's my interval from negative 2 to 2. Both endpoints have the same y value. So 0 minus 0 over 2 minus negative 2 would be 0. So basically, the mean value theorem says that I have to equal 0. And this problem is saying there is no place where your derivative equals 0. So what's wrong? Well, the mean value theorem has 2 conditions. It says we have to be continuous and we have to be differentiable. But this problem says that we're just continuous, which means the issue with this must be that we're not differentiable. So, if I read through these options, the last option said for some k between negative 2 and 2, the derivative does not exist. That means it's not differentiable, which it needs to be. So this must be the reason why I don't equal 0 for my slope. A free response example for mean value theorem is, let f be a function that is differentiable for all real numbers. The table above gives the value of f and its derivative f prime at selected points between negative 1.5 and positive 1.5. The second derivative has the property that the second derivative is always greater than 0, so it's always positive. Find a real number having the property that there must be a c between 0 and 0.5, and f prime of c equals r. Give a reason for your answer. So basically, tell me what number you can guarantee the second derivative equals. value Well, since we know some numbers for the first derivative, and the second derivative is just the slope of the first derivative, we can use the mean value theorem because we're trying to guarantee a slope of something we know between 0 and 0.5. So f double prime of c must equal f prime of 0.5 minus f prime of 0 over 0.5 minus 0. F of b minus f of a over f b minus a, only now we're using the first derivative to guarantee a second derivative value. Whereas normally we use the original to guarantee a slope, we're using the slope to guarantee the slope of that. We're taking one step further. Basically, this is just supposed to remind you that you can use mean value theorem even if you're going from first to second derivative, not just from original to first derivative. So, f prime of 0.5 is 3, minus f prime of 0 is 0, over 0.5 minus 0, which means I have 3 divided by 0.5, which is 6. So here's what we can say. Since f prime of x is continuous and differentiable, f double prime must equal 6. Oh, I'm sorry, I should call this r because the problem is calling it r. F prime of r must equal 6 for some, oh no, the problem calls it c. What am I talking about, guys? F prime of c must equal 6 for some c value between 0 and 0.5 by the mean value theorem. And we're done. Like I said, I know this was a much longer video and you had probably to break it up into chunks and watch it in pieces, and that's okay. I appreciate you guys sticking it out and going through it, and we will definitely spend some time talking about this over the next couple days. Thanks for watching.